Hello everyone, so today we're going to go over the second part of the Unit 4 practice test, the problems part. So we'll begin with a division question here. So first we'll draw our box for division. Here we have 2 on the left hand side of this vertical bar, and then we have the coefficient in descending order, so 4, and then -4, and then -24, 0, 32, and finally -1. So notice that we have to add the 0 here, since in the polynomial there is no x squared term. Okay, so the first 4 gets carried below the horizontal bar. 2 times 4 is 8. And the sum here is 4. 2 times 4 again is 8. The sum is -16. 2 times -16 is -32. The sum here is -32. 2 times -32 is -64. The sum is -32. And then the product is -64. And the final sum is -65. So the quotient here will be 4x to the 4th power plus 4x cubed minus 16x squared minus 32x minus 32, and we have a remainder of -65. So the question specifically asks for a division statement. So the division statement will be written as first the dividend. So we have the dividend from the original question here. I'm going to rearrange the terms in descending order. So 24x cubed, and then 32x minus 1. And that's equal to the divisor, so x minus 2 in this case, multiplied by the quotient of 4x to the 4th power plus 4x cubed minus 16x squared minus 32x minus 32, and then plus the remainder of, or subtract the remainder 65. Okay, so the second question we have, it's very similar. We have a factoring question. So here we're going to try the factors of 30. So that will be plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, and then plus minus 10, plus and minus 15, and finally positive or -30. I'm going to start by trying the positive integers first. So first one we'll try is 2 times 1. I'm going to use a different color here for a second step. So 2 times 1 cubed plus 9 times 1 squared minus 11 times 1 minus 30. And we're using the factor theorem to see if this is equal to 0. So we have 2 plus 9 minus 11 minus 30. So that's not equal to 0. So x minus 1 is not a factor. So next we can try x minus 2. So we can substitute in 2 into the polynomial. Okay, let's see here. We have 16 plus 36 minus 22 minus 30. So that is equal to 0. So therefore, x minus 2 is a factor. So now we can go ahead and divide. The polynomial by x minus 2 using synthetic division. So this would be 2, 9, -11, and -30. And then 2 on the left-hand side of the bar. So 2 times 2 is 4, sum of 13. 2 times 13 is 26. gives us a sum of 15. 2 times 15 is 30. Gives us a sum of 0. So the quotient is going to be 2x squared plus 13x plus 15, which we can now factor. So that is the next step. So here we can factor for a number of different ways, one of which is factored by grouping. So we're looking for two numbers that have a sum of 13 and a product of 2 times 15, which is 30. So this would be plus 3x plus 10x plus 15. And then regroup the first two terms together and the last two terms. Greatest common factor in the first two term is just x. So we have x times 2x plus 3. And the greatest common factor in the second two terms is 5. So we have also here x plus 3 in the parentheses. So the two factors that we have are x plus 5 and 2x plus 3. That means that once the polynomial is completely factored, we have three factors. The first one was x minus 2 from the combination of integral zero theorem and the remainder theorem, after which we divided, and then we have 2x cubed plus 13x plus 15, which we factored into x plus 5 and 2x plus 3. And that is the original polynomial factored completely. Okay, question number 3. Okay, just a table here. So we have the degree, so 5. Again, looking for the highest power of x. So 5, 4, 2, 3, and 5. 5 is odd, 4 is even. Actually, I'm just going to use a different color here. Okay, again, odd, even, even, odd, and odd. Of course, the important part about the degree being odd or even is that it determines the end behavior of the polynomial, well, the odd and even degree and also the leading coefficient together determines the end behavior. Next up we have the type. So degree 5 is quintic. Degree 4 is quartic. Degree 2 is quadratic. And then degree 3 is cubic. And again, last one is quintic once more, since it is degree 5. Next we have the leading coefficient, so -1, -4, -4 again, -2, and finally 4. Okay, we're also looking for the constant terms as well. The first constant was -2. So the question asked for the y-intercept of its graph, but that's just the constant terms. So -2, 5, -7, 3, and finally the last one, there's no constant term per se, so the constant term is just 0. Okay, so that's number 3. Let's move on to number 4, matching graphs to equations. So the first equation is negative quintic, so we know that the graph must come from quadrant 2 and end in quadrant 4, so therefore is graph C that matches with A. So this is again odd degree negative. Okay, let's move on to the second one. This is cubic, so it's odd degree again, but it is positive, so that will match up with graph A. So this is equation B is graph A. And afterwards, the third one, this is even degree, but positive, so that must be graph D. And finally, last one, we are looking at even degree but negative, so that must be graph B. Okay, so that's it. Question number 4. So let's move on to question number 5. Okay, the product of 3 even consecutive integer is negative 480. So it says to find the integer using a cubic polynomial equation. So the first step is to set up the 3 consecutive even integers. So we will let n be the first one. And then n plus 2 will be the second. Because they are consecutive and even, they must be 2 apart. And then n plus 4 will be the third. Okay, so the next thing that we know is that the product of these 3 integers is negative 480. So that would be the equation negative 480 is equal to n times n plus 2 times n plus 4. So we can multiply this whole thing out. Multiply the binomials together first. So we have n squared plus 6n plus 8. And then we can multiply the n. So that will be n cubed plus 6n squared plus 8n on the right-hand side. So finally, move the 480 to the right-hand side. So the trouble with this kind of question is that 480, for example, has a lot of different factors. So in all likelihood, we are going to be given a few to try out for the combination of factor theorem and the integral zero theorem. So in this case, we are going to try, let's say, 10, or sorry, negative 10. So we have 0 and then negative 10 cubed plus 6 times negative n squared plus 8 times negative 10, and then plus 480. So this would be, of course, negative 1,000 plus 600 minus 80 plus 480, and that is equal to 0. So we know that n minus 10 is a factor. So the next step is to divide. And so we will divide here. We have the 10. Oh, sorry, n plus 10 is a factor. Sorry about that. Okay, right. So here we have negative 10, and then the coefficients 1, 6, 8, and then 480. So 1 gets carried downwards. Negative 10 is the product. Negative 4 is the sum. 40 is the product. 48 is the sum. And then negative 480. So we have remainder of 0 as expected. So the quotient is going to be x squared minus 4x plus 48. Now we need to show that there's no other factors and therefore no other solutions here. And we'll do that with the discriminant. So b squared minus 4ac. So in this case, this would be negative 4 squared minus 4 times 1 times 48. So if we were to expand here, we can see that this is going to be less than 0, so there are no roots. So that is to say then that negative 10 is the only solution. So if negative 10 is the first integer, then our three integers will be negative 10, the first one, negative 10 plus 2, which is negative 8, and finally negative 10 plus 4, which is negative 6. So those are three consecutive even integers, and they do have a product of negative 480, so that checks out. And that's all the steps for this question, and that concludes also the Unit 4 practice test. So thank you for listening.